Howdy, everyone. So, hey y'all, my name's Mitchell. I am part of the Specs product experience team. I'm a design engineer, so constantly prototyping new stuff, and I work on a lot of the AI experiences and sample projects. I'm also probably the person who's talking to myself the most, just because I'm constantly giving voice input. So, yeah, I'd like to introduce a new sample project that I've been working on and that we're releasing today. So, let's get right into it. I'm calling it Agent Center, and essentially the TLDR of what this is I made a lens that lets you connect to your Claude code, your codecs, your OpenClaw, whatever like CLI agent that you want to use, as well as a couple cloud agents from your spectacles. You can give input to them with your voice, with your camera, with Bluetooth keyboard, all supported on Specs. I have a QR code right here if you'd like to take a look at it on the GitHub, but it's part of the Specs Dev sampler repository now. So what we're gonna do is I'm gonna go over this project, how I went about creating it, what it is, why I created it, as well as do a live demo of how this works, how I think through making experiences on Specs, and we'll open it up to questions after that. We're gonna talk about like why, what, how, when, why did I do any of this, what did I learn, do a live demo, questions. So what actually is this? This is a lens for connecting to various coding agents that you're running on your own computer. Primarily Claude Code and codecs are the ones that I focused on, since those are the ones that I use the most in my day-to-day life as a prototyper. And what a coding agent is, pretty much at its like fundamental, is it's a large language model that's basically running in a loop that has been given access to tools or just the ability to access the various files on your computer. A lot of these are accessible through CLI, but you do also have a lot of consumer apps which are coming out, but I wanted to focus on the CLI section since that's what most developers are doing. These can run locally, or some can even run in the cloud, dependent on which one you're using. Why did I actually make this? Well, I think there's a lot of challenges with actually using coding agents on desktop. This is a pretty common example of what any of my monitors looks like at any time. I'll have like 27 Claude Code sort of conversations that I never clean up. I'll have like 6 running at a time. Since I'll start one, it'll take like 10 minutes to finish a task. So I'll be like, well, what's another task? I'm just gonna start another one. And then suddenly I end up with this just like wall of terminals that it's really hard to tell what's going on. You can't really quickly glance at one of these and just tell what exactly it's doing, what state it's in. You can like jump in to give input, but usually it takes a little bit to just have that context switch of what's happening, and these are completely acontextual. Like just looking at these, it's a bit hard to tell, is this all for one project? Is this all working on the same stuff? What's going on right here? And I oftentimes find myself actually recreating the same chat over and over again sometimes because I'll just be like, oh wait, I forgot that I was even talking about this to another terminal. So my big challenges with a lot of these CLIs is it's difficult to review output, it's difficult to multitask, it's difficult to context switch, and also like, it's also kind of tiring sometimes to just be at my computer constantly where it's like, all right, one more prompt will fix this. So I wanted to make sure I could feel comfortable leaving my computer. Also, people have their own very custom LLM setup, so the reason why I integrated with these existing CLI agents that exist today is because, well, people do a lot of work to get their LLMs properly set up on their computer. I have like a bunch of my own skills. I'm sure a ton of you have your own skills as well. I have my own pipelines, and just getting somebody to put in all that work to set it up on a new agent can be a lot of bandwidth that somebody may not want to do. So here's what I built. Essentially, what this allows you to do is you can have multiple agent chat threads all around your desk with these very quickly glanceable robots. The robots have these different animations for showing what state they're in, if they're requesting permission for something, if they are currently working on something, if they're idle, if they're unreachable. And you can pull up agents from all your different CLIs with one unified UX. So you can have your codecs, your cursor, your Claude, your OpenClaw, all next to each other, all coexisting. You can quickly type to them with your keyboard, as well as you have this cross-device continuity going on where you can actually pick up conversations back on your computer after starting them on your specs. So what's nice about this is you can really just glance and see all these different things going on, and you can start spatially organizing them too, which is pretty fun. Like maybe I want to have all of my stuff related to one project on this side of my desk, all my stuff related on this other project on that side of the desk. So I can quickly create these like spatial relationships between what agents are doing, what they're working on, and quickly just get a sense of what's happening. I also worked on some on-the-go features, so quick voice notes was something I wanted to do since I think a lot of people have their best ideas while walking. I wanted to make sure I could easily just at any time give voice input to an agent without needing to go through a complicated UX. So I have this very simple voice note UX where you can see here's me at Santa Monica Beach just telling Claude to send a message to one of my coworkers, and also notifications. So if I've stepped away from my computer and one of my agents finishes, I get a notification. I can then action on that notification to then do some follow-up actions. So the way this works at a high level is this project is split into 3 different components. We have a bridge daemon, so this is what actually runs in the CLI right here, and this basically interfaces with all of the different CLI terminals for the different agents. We have Supabase, which acts as an intermediary, so that's where data transfer is happening. And then we have the Lens client, which is where we have all our fun visualizations, all our fun little interactions. So we'll kind of go component by component, and I'll go through a couple examples of how data transfer goes. So the bridge daemon is essentially this process that runs in your terminal. It has this fun little terminal UI with animations I made, where you can pair these various agents. You can kind of scope what repositories you want them to work in, as well as what models you want to be able to access from your specs. And what this does is, under the hood, every time that it receives a message, it will spawn a new terminal instance of that specific agent. It will await the output of it, and then it will send that information back over to the user. And each different agent requires a slightly different driver. The way that you call Claude Code is different from the way you call Codex. So the driver is like the custom work per agent that you have to do, but ultimately adding a new agent is just making that driver, which is pretty easy. I also store all of the user data locally on the computer. And the reason for that is like twofold. One is a data privacy perspective of your computer has access to all this data. Your computer should be the one that's gating who has access to that data. So we shouldn't be just sending all of your file system over to your spectacles. That would be a bit too much. So we only really send information as needed from your computer to your specs. The other additional reason that the data is actually scoped per computer is a data governance perspective with regards to being able to support multiple computers. So I don't know how many people have used OpenClaw or these various allow all sort of agents, but I probably don't want that mixing with my work agent, which is a bit more scoped down with regards to what it can access. So I want to be able to talk to both in the same interface without any worry that one is going to accidentally send all of the secret spectacles information to my Twitter account. So data scoping is important. Additionally, I added a couple MCP servers on here. One is something I call the permission server, and this is one that will actually interject in the tool call pipeline for these agents, such that it'll send a pop-up to the Lens, such that the user is able to say approve or deny or allow all, as well as something I call an artifact server, which is a server which is able to take screenshots on your computer, send that to spectacles. So if you're working on a Lens and you want to tell your agent to do something in a Lens, you could then have it screenshot and send you the output whenever you're away from your computer to know what's going on, as well as things like code diffs and different sort of text file rendering. The next component is the SnapCloud component. And this part's pretty simple. We have a couple different edge functions for just communicating across the client and the computer. We also have one primary table, which is where the pairing occurs, and that's this bridge agents table. So that's where we have who is paired to who, sort of combined to each other. So with the pairing relationship, we have real-time broadcast for sending messages over to one another, and as well as some reliability aspects. And I'll go deeper into this later. And for the actual spectacles lens, this is the fun part. We have various input UIs for voice, BLE keyboard, camera crop gestures, so you can take pictures of things, you can send a quick voice note, or you can even type to it if you prefer to do that. We also have the ability to create simultaneous agent threads. So something you'll see right here is I have 3 different robots, and each of those is a different task. And whenever you start a task, you can actually drag it off of the main UI to be one of these little side things. So if you want to give input to another thread and start giving input to that, you can do that. You have full control over deletion of that thread as well, what repository it's working in, as well as some smart features which I added on top of this with Remote Service Gateway. So one of the things that I really wanted to avoid doing is getting in the way of how people use their agents. I tried to avoid really getting into people's system prompts or changing people's workflows. And instead, I started thinking about how can I build on top of this while respecting people's privacy, and I think that these smart features are a good balance of that, where we take the user chat data that is going through the lens, and if the user opts into this, they can do things like permission explanations. So if you get a complicated bash script that one of these agents is trying to do and you want a quick explainer, you can call that. It sends it over to a flashlight model. You get an explanation of what it's trying to do. A smart topic renaming. This is a pretty common thing that you have in various AI IDEs, where it will rename the topic that you're currently on dependent on user input, as well as summarization, so you can know like, what the heck was I even talking about? So as an example of data flow, I think verification is a pretty good example of this, where it starts in the CLI, and you essentially pick what kind of agent you want to add, you give it a nickname, and this will call a function on Supabase that will then generate a 6-digit code, put that in the bridge agents table, and then on the lens side, we're just sort of like waiting for a user to put in that same 6-digit code to this table. That will create a match on this table. It'll close that for pairing, and then we send a signal to both parties to start a broadcast. So that way they can start exchanging data. We have a similar thing for messaging, where messaging will start on the lens side, and essentially what this will do is the user will give some form of input that will then be passed to something called a bridge agent provider, which formats the message into the proper format for the Supabase instance. That gets sent over the bridge agent, which then gets sent to the CLI. The CLI will then spawn a process of whatever agent that it wants to communicate with, and then that eventually gets bubbled back over to the lens whenever we have an update. And we're only really awaiting that information if a user is sending that, or if this is kind of like a previous process that the user has requested or wants to see topic updates for. So really trying to avoid constantly sending all the information to the lens. Some lessons I learned while actually making this project is really to just dive very deep into programmatic creation. The more you can figure out ways of representing things via text, the more you can get AI to create assets for you. I don't really use 3D mesh generators that much, since I can't quite get the follow-up sort of like prompting that I want with them, or I can't really get the UVs to be exactly where I want. So something I've started doing is I actually get AI to write me Blender scripts, and then I run those Blender scripts in Blender to actually create meshes. And that's how I created all the assets for this project, via Blender scripting, pulling it into Lens Studio, we now have like these custom code nodes, which can be represented via script, which is really awesome. So you can then get AI to really write powerful shaders for you. So the actual shader that I use for the agent, there's actually no textures involved. Instead, we use sign distance fields for doing all the animated faces. And it's a mix between sort of like mesh animation, SDFs, and blend shapes, which are all generated via AI. And what's really nice about that is it's very controllable. So if at any point you wanted to make a change, like maybe you want to slightly adjust the geometry, you can actually hop into Blender yourself. You can make that change. You can make that change to the script. So this is really nice for getting very reliable generations. The other thing which I started doing is actually generating my own dashboards for asset generation. So there's a lot of like music and sound generators out there, but personally I really like actually generating all those sound effects via code. So I get AI to essentially use code to create little dashboards for me to create sound effects, and it will use various audio libraries for creating sound effects. And what's nice about that is you can then ask for specific controls. So maybe you want to change sort of like the echo duration or the attack duration, and you can really get these very custom UIs for exactly what you're trying to achieve here. The more you can like find ways of creating these asset generators, I think that the more control you can really have over creating assets for your projects, and also just make it very reliable such that you're not constantly prompting for the same thing and just trying to one-shot what you're trying to get to. I also find that usage of very specific vocab goes a long way. So whenever you ask AI to just make me a 3D robot, that might be something that it could struggle with. But the more that you can ask for specific aspects of how 3D modeling works or how 3D shaders or materials work, the closer you can get it to really do what you want it to do. And I think that using AI to really explore what you can even do in these spaces also helps a lot. One example is I wanted to create animated faces. I didn't want to make a bunch of textures because if I wanted to add a new face, that would be a bit more work to add those textures, to store those textures, to update those within the lens. So after kind of like asking around about procedural meshes, I learned more about sign distance fields, and learning that I could use sign distance fields as a render target on the actual meshes themselves made me get these really cool effects on the like little characters. And by just knowing that I could use SDFs, I was able to really set it in the correct path that I wanted it to go down. Something else, which I'd really sort of talked about from like the both AI UX side of things as well as the just using AI perspective, is making AI applications. Like most of it is just, can you make a cool loader? Since especially like as you balance how long these different models take, you have to really think like, how long is a user really willing to wait for something to happen? If something will happen in under a second, you don't really need much of a loader, but as soon as you hit that like 5-second threshold, you need to really start making these very engaging loaders for how people are using these. And once you have multiple minutes, you probably aren't gonna have somebody who's just staring at a loader the whole time. So you need to start thinking about like, how do you make sure that you're showing statefulness and just getting the user to look back at what you want them to look at whenever they need to look at the output. So the better you are at making loaders, the better you are at making user interfaces for AI. This was something I also learned when making the Imagine Together experience, where that was a 3D generation experience on Specs, and essentially showing stage by stage what's happening can be very engaging. So really learn a lot from loader UX when you're making these experiences, since I think there's a lot of lessons to be learned with regards to timing, with regards to how long are people willing to wait, and what you need to be showing people if you're taking certain lengths of time. It's also really nice to just have parallel items in generation. That's something I learned with Imagine Together to an extent from a user perspective with regards to you want the user to almost forget about the fact that they're already waiting for something by making them wait for another thing. So the more people can kind of parallelize what they're doing, the easier it is to wait for things. And this also applies to actual development. By having this project be 3 different components, it made it a lot easier to just parallelize work, since I could have it to where, okay, I have like one agent that's working on this UX part of the project, one that's working on the terminal, one that's working on the cloud, and I can sort of swap between those as I wait for another to complete. So that's like the primary lessons learned, and I'm gonna also hop into the project in a second, and we're gonna hop to a bit of a live demo. I'm gonna open up my Lens Studio project. So this is the project itself. Something you'll notice is it's pretty sparse from a scene hierarchy perspective. We have like this requirements item. We have this guide, which we're just gonna disable, which is just some information about how this works. We have our remote service gateway credentials, an API key hint, which we can also disable. But really, almost everything happens within this agent manager controller object. And I'll show you in a second as we get the project running what that's doing. But the hint is it does a lot of programmatic instantiation for just getting everything running. So to get this project to actually run, we first want to set up a Supabase project, so that way we can connect to the cloud, and then after that connect to our Mac itself. So in order to do that, you just want to use the Supabase window. You can log in, and that will essentially bring you to the screen right here, where you can look at your various Supabase projects. We're going to create a new project. We're going to call this one, like, I don't know, Agent Center 2. We're gonna give it like a really good password, and by give it a really good password, I mean I'm just gonna like smash my keyboard a bunch until I get something that I don't even know what the password's for, so therefore it's really secure. And we're just gonna create the project. Claude Mythos could not get into this project. We are that secure with our password generation. So we have a Supabase project, that's awesome. If you actually click right here, you can see your various like API keys for connecting to your Supabase project. We're just gonna grab this little project ID right here. So just gonna copy paste that, go back to our Lens Studio project, and what we're gonna do is in the asset browser, let's just collapse all of this. We are now going to create a Supabase project. So let's pull that in, and this is our Supabase project. On the Supabase project, we want to put in our project ID, project URL, and token. So what I'm gonna do to do that really quick is I'm just gonna open this in Cursor. And I'm just gonna put all of this information in right here. So let me just copy that over real quick. And my public token is right here. So let me save that, go back here, double check that's applied now. We're gonna just drag and drop this over into the Supabase project. So now, if that happens, we'll see this sort of like loader that is trying to connect to the bridge, and it will probably tell us that we have no agents that are paired right now. We are getting a 404 request, a 404 response right now. So it looks like, okay, yeah, so it's trying to connect and it just isn't able to do those edge functions right now. And that's because we don't have anything in our project. Our project's completely empty. So something I did to try and make setup for this project as easy as possible is you go to the terminal, you want to go into the Supabase folder. I created a script called setup.sh, and this basically uploads all of the edge functions, all of the database policies. So this is all the hard work with regards to setting up your project, and we just want to pass our Supabase credentials into it. So we're going to pass in our project ref, it's going to link to the project, and it will start doing everything that it needs to do. So it does a little migration. We can get it to generate secrets, and it's going to start uploading all of our edge functions. And because I love to terminal max, we're gonna also have this right here, and we're gonna go over to the bridge. And this is where we're going to have our CLI portion, and we're going to start setting that up soon. We also want to bring in our anon key, which we can get from this right here. So grab that, paste that, and cool. Our backend should be set up now. So if we actually look at Supabase, we should see we now have a bunch of edge functions. We got our database set up right here. So now all we have to really do is just connect to that, or connect our computer to that. And for that, what you want to do is in the bridge, this is where we have all of our terminal UI stuff. So you're just going to npm install that. And once that's installed, you can either run npm link to create a little shortcut for this, or you could do node sync.js to just run the function locally. And this will create the agent bridge right here. So we have this fun little terminal UI for this. Now if we wanted to pair an agent to our specs, let's just double check we are connecting here. So we can go to here on the actual project, we can press connect, and then on the terminal UI itself, we're gonna press add new agent. We're going to give it a Claude code, which we can give the nickname of like Claude or Claudie or something. This will give us a 6-digit code, which we'll then copy, and we can paste into here. Little useful thing right here. If you have device type override set to spectacles and you have no simulation set in your preview, you can then just use keyboard input, which is nice. Now if we press pair, hopefully this should all work. And yeah, we have our agent right here. So we have Claudie. And what we can do is, you can go back to the terminal UI, we can give it permission for screen share, so that way it can take screenshots. And now anytime that I activate all agents, you can see this will wake up the Lens UI, and we can start giving input to our Claude Code instance. So it's gonna try and fetch conversations, see that there's none, and then we can start like new chats, and we can give it some workspaces. We can also go into the settings, and we can do things like change the themes. So if you're a big cat fan, I have a little cat theme. Also have an axolotl. This one has like fun little blend shapes on the side. So we got all these fun little characters right here. Additionally, from the smart features perspective, we have all of these right here for smart summarization, prompt suggestions, topic renaming, permission explainers. This looks broken on Lens Studio, but I swear it works on device. So we'll show that soon. But yeah, we can start giving input to Claude Code now on our specs. And I'm gonna do one more setup step. I'm gonna give this access to all of this actual exact repository so we can make changes to this repository from our spectacles. In order to do that, I'm just gonna need to turn off screen sharing for a second so that way I can avoid showing all the secret stuff that we're working on. So we have our little guy right here. We are in spectacle samples. We're gonna configure a couple settings. So I'm just gonna enable all of the smart summarization, prompt suggestions, topic renaming, all that stuff. And we're just gonna try and give input to this. Hopefully we have good enough Wi-Fi. So I'm just gonna tell it to look at the README for this project. Hey Claude, can you do me a favor and please look at the README for the Specs Agent Center project and just give me a little bit of feedback? And then we can send that over. Okay, awesome. It looks like it was able to accept that since it looks like, yeah, it was accepted on the terminal right here. It's going to start working on that. And as this is running in the background, we can just grab this and we can drag it over to the side right here. Oh, I think I actually forgot to do one quick setup step. If you want to use any of these remote service gateway smart features, you're going to want to go and generate your tokens. So we're just going to copy and paste these in here. And this essentially allows us to do these real-time assistance for AI answers. So that's going to be on there now, and we'll repush in a second, but it looks like we actually just got a response. So yeah, it looks like we're getting a little bit of feedback on our project now, and it says it's overall pretty solid, but okay. It looks like it's telling us that I made a little bit of a mistake with regards to some of the pathing, so we're going to update the samples live from Spectacles. So I'm just going to drag this over here. I can either type on here, or I can give voice input. I'm going to choose to give voice input. Might have to fix that collider right there. Or I can also just open it from here, since it should be fixed there. Yeah, can you do me a favor and patch those? And we can send that. That'll start patching that. So we'll come back to that in a second. But if I wanted to start a new chat, I can always just start a new chat here. And I can also work on a similar thing. Like maybe I want to ask it, what are the latest Git changes for this project? Then we can have that one running right here. And we can have another one running where maybe I ask for, hey, can you show me a screenshot of what's currently going on my computer? And we can start running that one. But it looks like our latest Git changes has had an update. So we have our latest commits right there. And now that we're done with that conversation, we can always delete it. So we can just blow that up right there. I love my shaders. So it's going to kind of like keep working in the background on that. But say, for example, this is a more complex task. Something which you can actually do is you can always go over to your chat. We can always press open in CLI, and this will actually open that Claude Code conversation on your computer in case you need to give more detailed input. Okay, it looks like it's asking for permission now for making that change to the README, but maybe this is like way too much text. I can always just press explain, and this will then run our remote service gateway to summarize that, but I didn't have those credentials in yet, so we're just gonna push that back over, and we can hopefully resume with those assistive tools. So we're gonna open up back up the project. We're gonna go right here. Yeah, and it looks like it is, we should now be able to just get a little explanation of what it's currently doing. Okay, so it's trying to update the README. Maybe I'm just gonna auto allow this for the rest of the session. And at any point, if I also want some help with regards to like, hey, what can I do here? I can always hover over this. This will use Remote Service Gateway to summarize the conversation and give me a couple suggestions. So that way I can always quickly give input without needing to give voice input. I'm gonna pull out, I have a Bluetooth keyboard right here. I guess this is a better way to show it. We can always turn this on. We can go over to our overall settings, which we have for the project. We can pair this, and I'm just gonna bring this over here. We're gonna start pairing this to my spectacles. Looks like it's showing up now. If I ever want to give additional input, I can always now use my keyboard. So I can just say, hello world, and we can type that to our agent. So this starts to get pretty powerful for a workflow, especially as you have a lot of multitasking going on, and yeah, it just becomes a very fun project. Okay, it looks like this one wants to do desktop screenshots, so we're just gonna take this, I'm gonna put it over here. I think it'd be nice over there. We have our screenshot right here, so let's say I had kind of like a bit of code I wanted to look at, I can now sort of like easily reference this as I work. Or if I'm on the go and I wanted to see what my agents are doing. So yeah, that's the artifact server in action. But let me show you a bit more about how the project works, since I think this would be a pretty cool opportunity to do that. So hopping back into the project, now that we're back in Lens Studio, I'd like to show you a little bit more about how I overall structured this project. So it can be a little bit unclear just looking at the scene hierarchy. Something I do is I actually don't use the scene window at all, but I really only keep my Lens Studio open to see my preview, my inspector, and my logger. And if I actually go over here and we press on the preview inspection, you'll see that I pretty much instantiate everything programmatically. So we sort of split things between like gesture, input, and the actual stateful UI. So you can kind of go through and see that this is all just instantiated from primarily this agent manager panel for the stateful UI side of things. We have the input bar, which manages things like the Bluetooth keyboard, the audio input, the camera input, We have this hand-docked menu for summon, unsummon, and the voice note gesture for the quick voice note. The reason that I do a lot of this programmatic instantiation stuff is because it avoids a lot of the issues with regards to linkage. So if at any point there's some issue with my project being corrupted, it's a lot easier to recover from this state. It also makes this a lot easier to generate new views from. So if I pass my scripts to AI and it's able to see, here's how I programmatically create all my UIs, it's a lot better at generating new views this way. So if at any point I want to generate a new aspect of the settings page, or I want to generate a new page of a new feature, it's a lot easier to give it this text-based content, and then also just generate a further part of the project. So I think this programmatic instantiation strategy is pretty good for that. The other thing that it's nice for is I generally try to avoid having nested prefabs. And if you want to do essentially nested prefabs, you can do that through programmatic instantiation by having it instantiate prefabs as needed. Yeah, programmatic instantiation is a good way for just getting AI to continually build new parts of your project, as well as is a bit more scalable in my experience compared to scenes with a lot of components, scenes with a lot of prefabs. So you'll see it has all these different themes. It can enable, disable. It has state overlays, which are all created meshes, and it animates these via scripting primarily. So almost everything done in this project is done via scripting. There's very little manual asset creation. So that's the overall project. What I'd like to do with the rest of the time is open this up to questions.